All right, welcome back to Spring Into Math 5. This is Mr. Stein here again, and today we're talking solving real-world problems with multiplication of fractions. Okay. So we're going to solve essentially word problems by multiplying fractions together. All right, so we can use models to show how to multiply fractions. We've done it before. First, let's look at a real-world example. After a pizza party, there were 3 boxes of pizza, each with 4/5 of a pizza left. So how much pizza was left in all? Now this really comes into play, especially as you get older. You host a party, you have a bunch of pizzas. At the end of the night, you have 3 boxes with 4/5 left in it. How many pizzas do you actually have left over? How much did you overbuy? Okay, so let's use a model. So here you can see we have our 3 boxes of pizza, and I'll kind of circle them for you. And they have 4 of 5 slices still left. And so if you think about it, it shows if you were to add them all up, you have 2 full pizzas and 2/5 of a pizza. So let's look at it kind of mathematically. So we have 3 times 4/5. Well, anytime we multiply a whole number by a fraction, we're just going to put that whole number on top of 1 so that it makes it simple for fraction-wise in terms of multiplication. So we think 3 times 4 is 12, 1 times 5 is 5. Because remember, you're going to multiply numerators and you're going to multiply denominators. So now you have 12/5. So you have 12/5 of a pizza left over. Obviously, that's not going to really help us a lot. We don't want to leave something like that in an improper fraction form. That's not going to be related to real-world problems. So then we have to turn that improper fraction into a mixed number. We're thinking 12 divided by 5 because you take your numerator, divide it by your denominator. Your whole number is your whole amount of pizzas left in this case. And then you put your remainder over your denominator to give you your fraction. So 12 divided by 5 goes in twice with 2 left over. So you have 2 is my whole number and 2/5 of a pizza remaining. And you can see it represented by the model as well. Okay, so you can also use a number line to multiply fractions. So we have 3/4 times 5 this time. So we're going to make a number line and we're going to start at 0 and we're going to mark them in terms of 1, 2, 3, and 4, etc. So let's take a look. So you have I start at 0 and you can see I'm just kind of marking it because I'm marking fractions. And I'm not going to worry about getting to 1, 2, 3, even though it really does come into play. 4/4, 8/4, 12/4, 16/4. Obviously those are your ones. So if it helps you to think about it like that, you got 1, 2, 3, 4, 5. Those are your whole numbers because 20 divided by 4 would give you that 5. All right, so now let's look at it. So we changed the whole numbers into improper fractions so that you can kind of see it. So you see that each thing has a denominator of 4. And so now we're taking 3/4 times 5 means that we're going to jump 3/4 5 times. And so you can see here I've jumped it 3/4 each time. And if you're really to look at it closely, it's 1, 2, 3. Each jump is the 3 of 4, 3/4. So you can see here I have 3/4 plus 3/4 plus 3/4 plus 3/4 plus 3/4. And so if you see right here, you're 1 before the 16th fourth, so you're going to have 15/4. And so by doing that, you're going to have at least 3 as a whole number. Okay? And so then if you looked at that like that, you'd have 3, which is right here, and then you have 1 extra 3/4 jump. So you have 3 and 3/4. Okay. So we're looking at that 15/4 relationship. So if that was a little hard on the number line, I get it. It's, I don't think it's real practical to set up number lines for every type of question. I think you just multiply it across like we've done before, and then you just convert that improper fraction into a mixed number. And I think that's the easier, more accurate way to do it, on an everyday basis. So then we have 15 divided by 4. Well, that's going to go in 3 times with 3 as my remainder. So 3 is going to be my numerator over 4, and my whole number is 3. So I get 3 and 3/4. All right, so let's look at another real-world problem. So we have Diane, and she claims that it takes her only 6 3/4 hours to complete her homework every night. Carlos thinks he can finish his homework in 2/3 that time. So how long does Carlos think it will take him to complete his homework? Now, when you see this, a lot of times you're thinking, I'm confused. I don't know what to do. But remember, a good way of thinking of multiplication, of fractions especially, is that if he thinks that he can do it in 2/3 of 6 3/4 hours, that of is your tip-off that you're going to multiply. So you're going to set it up as a multiplication question. So we want to know the length of time Carlos thinks he needs to complete his homework. what's the relationship of this length of time to the length of time Diane requires to finish her homework? So if we let D equal the amount of time it takes for Diane to complete her homework, then we would say that the length of time it takes Carlos to finish his homework is 2/3 of D, or 2/3 times D. That's a simple multiplication problem. So then we just solve 6 3/4 times 2/3. And remember, it doesn't matter if you do 2/3 times 6 3/4. It's really the same because, multiplication can be flip-flopped. It doesn't matter in terms of the order. So we convert all mixed numbers to improper fractions, and that just makes it easier. So I know we've talked about other ways to do it, but when you multiply it, you have to convert it because you're going to multiply the numerators and you're going to multiply the denominators. It's not like adding or subtracting where you kind of do the whole numbers separate than the fractions. This has to be in one fell swoop. So we need to convert that mixed number into an improper fraction. So we're going to take our denominator 4, and we're going to multiply it by 6, our whole number. So we have 4 times 6 is 24, plus our numerator, which is 3. So that gives us 27, and we're going to put it over the denominator of 4. So now we have 27/4. So now we're going to reset up that multiplication question. We have 27/4 times 2/3. And now we just simply multiply across. So we have 27 times 2 is 54, and 4 times 3 is 12. Now, obviously, we're not going to leave it as he's going to do it in 54/12. That's not going to really mean anything to you in terms of how long it's going to take Carlos to do that homework. So we got to take that improper fraction and convert that thing right back to a mixed number, and then voila, we got our answer. So we have 54 divided by 12. Well, that's going to go in 4 times because 4 times 12 is 48, and if it was any bigger, it'd jump up to 60. So we have 4 as our whole number. We have 6 remaining, so we're going to put that over our denominator. So we have 4 and 6/12, and then we can't leave 6/12. We have to simplify that. Hopefully by now we're looking at, 6/12. 6 is half of 12. Easy, we're just going to make that a half, so we have 4.5. So Carlos thinks he can complete the homework in 4.5 hours, where it took her over 6. So that was that 2/3 of. Remember when you're multiplying two fractions together, you're going to get a smaller number. All right, so hopefully that kind of ties in the real world application. See you next time.